Hello, my name is Walter Unglaub, and this is Physics of Ripple Tanks. So we can consider a couple different types of ripple tanks. We can either consider the side view here in one dimension where I have one vibrator that causes waves to be induced in the medium, in the water. And I can actually construct standing waves in this ripple tank if I meet the resonance condition. So the resonance condition for a tank that is length L is n pi is equal to KL, where K is the wave number. And the wave number is given as 2 pi divided by the wavelength of the wave. So if I substitute this into the resonance condition equation, I get n pi is equal to 2 pi over lambda times L. Therefore, this length L has to be equal to n pi times lambda divided by 2 pi. The pi's cancel out, and so the length of the tank has to be an integer number of half wavelengths. So if n is equal to 1, then I would get a standing wave that goes up and down like this. If n is equal to 2, then I would have one full wavelength inside my tank, and the water would oscillate up and down like this and switch off. And this point right here, the water would be stationary, it wouldn't move. This is called a node, whereas these points are called antinodes. So I can also consider from the top view of a ripple tank two vibrators that both operate at the same frequency, and they don't have to oscillate at the same amplitude. But if we consider the symmetry, we can consider the effect of two water waves interacting with each other in the same tank. So if this tank is large enough and the frequency makes it so that the waves are visible, we can consider the effect of constructive and destructive interference. So if we have a wave moving in this direction from this vibrator and another wave moving in this direction, well, these waves will move out isotropically, and so we can consider what happens when this wave interacts with this wave. And if we're interested in whether the waves interact in a constructive or destructive manner at this point, then we see that this extra distance that the second wave has to move is given by this angle here, and this distance right here, if these two vibrators are separated by a distance d, has to be equal to d times sine of theta. So the condition for the two waves to add up in a constructive manner would be d sine theta, this distance, has to be equal to an integer multiple of the wavelength. And if we have the destructive interference condition, then we would have to have m plus 1/2 of the wavelength lambda. So lambda corresponds to one complete revolution. But if we have an extra half of a wavelength, then the waves would add up destructively. So this would cancel out with this. And this is how you can analyze how waves interact and produce interference patterns using a ripple tank. So these are two examples of the types of physics that you can explore using water in a tank with vibrators that induce a wave propagating in the tank. My name is Walter Unglaub, and this is Physics of Ripple Tanks.